Hello everyone, I am Sorek, creator of Gauge.S. In this video we will go through new features and use cases of this sophisticated device, separated into 5 levels of complexity. Let's start with hardware changes. Quite a bit of time has passed since the first video of Gauge.S, and I never properly addressed changes to the platform. I tried to make everything as simple and backward compatible as possible. I'm very thankful for every person who trusted me with choosing my products, and I will always make sure future upgrades both to hardware and software will be painless as much and as plug and play as possible. When you get your Gauge.S, it doesn't matter which case and application you choose, they are all internally the same. Heart of this device is a small PCB board that is powered by a powerful dual-core microcontroller called ESP32. To run the device, you only need one connector and only few pins. The connector has 12V input, ground, K-line and EC pin, which is our button control, internally pulled up, so you only need one wire from the device to the button and the other end can be connected to the chassis ground, for example. For newer chassis, it's possible to reuse cruise control buttons connected to the device. For that, you need to connect your CAN high and CAN low lines. Functionality of cruise control is retained and device only responds if it's switched off. You do not need external resistor for K-line anymore, and from version 5.0 you do not need 120 ohm resistor for terminal between CAN H and CAN L lines, although in most cases it's not necessary at all. Those simple 5-pin ZH 1.5mm connectors is all you need to splice to your wiring loom or solder to your cluster. EA pin on main plug is used for driving PWM and PID signals to external components like gong warnings in E36, which in 5.0 version of the hardware, MOSFET is driven with a dip switch configurable weak pull-up, which makes it easier to use as it doesn't now require additional external circuit that in previous versions would require 3.3V digital level operation. Top left connector is mostly used for GPS and development purposes, and the last one is for analog inputs. There are two 0 to 5 pins A1 and A2, and A3 and A4 are 1 kΩ 3.3V pulled-up inputs for easy use of NTC temperature sensors. Version 5.0 have extra connectors there for even more configurable inputs and outputs. There will be separate videos about installing device into different chassis, but full documentation and instructions can be found on the wiki page on our GitHub repository at gauge.sorek.uk. If you want to play with your Gauge.S without a car, just hook it up to at least 5V battery of power supply, and then you can use button to navigate and familiarize yourself with the device. This is probably the highest level that most users interested in just displaying the parameters would need. Device is fully operational with just a single button control. You can single press, double press, and triple press to either move forward, backward, and use special functions. Long press works as a confirm button, and very long press enters or exits the menu. You can pick parameters with short or double press, then confirm with long press, and once parameter you choose lights up, you can use forward and backwards to scroll through different parameters to set up your screen however you like. Triple pressing in this mode lets you change display mode, and more display modes will be available in the future. Confirm to exit, or just wait till frame disappears after short timeout. If you triple press on main screen, you will see display is now surrounded with selected frame. Now going back and forth lets you choose predefined parameters of your liking in any grid configuration you like. You can set up to 9 separate screens and easily switch between them depending on your preference and current needs. There is also histogram or more XY plot of parameters you want to choose. If you select parameter here and then triple press, you can change viewing mode with or without min-max values and flickering trace. There are plans to add more interesting type of custom screens, so make sure to leave a comment what would you want to see added. Very long press on the main screen lets you enter menu. Here you can reset min and max values manually, log stuff to SD card and also set if your predefined login triggers should be turned on. Example of such trigger is checking if throttle is fully engaged to create wide open throttle type of lock. On the settings tab in the menu you can set things like the dimmer timeout when device isn't operational, change dimming brightness, enable device lock, which would require double press to unlock the device to prevent accidental operation. Note that fade brightness can also be set by external sources, for example cockpit lighting once analog input is connected and configured. Last thing in the menu is to restart to Wi-Fi, and to explain that we need to go one level higher. The best way to connect to Gauge.S to Wi-Fi is to set up access point on your phone with the name Logger.S and password Logger.S. The reason for it is legacy one, as Gauge.S was meant to be separate both add-on for Logger.S that works independently, and also because Gauge.S is too short for standard Wi-Fi password. You can also just start the device, and if it won't find predefined Wi-Fi connection, you will create access point with the same credentials. You can easily tell if it's connected, as by default access point IP will display as 192.168.4.1. Is it recommended to always connect device to internet when possible? Device works more stable this way and is also able to update its own firmware automatically. Once we are connected, we can type gauge.local or displayed IP address into web browser of your choice, and then wait for it to load. Remember that with external antenna you will need to be very close to the device to connect to it. There you can see SD browser and editor. Starting from top left, you can load files from your device to upload to Gauge.S. This includes config files and manual update files. Once you choose file, its name and location on SD card, you can hit upload. You can type folder and file names into the box and create using mkdir and mkfile buttons. Save lets you update the file you're currently editing. Restart lets you restart the device. And refresh will be replaced to restart to Wi-Fi in the next firmware iteration. The Gauge button is the new addition of firmware version 2.0. You will open new page when you can control your device remotely. You can use tap and holds as a normal operation, but it also supports swipe gestures, left, right, up for special and down for menu. Great for tablets, phones and Android heads units. Let's now see how to configure your screens. Press on config.json on the left panel and you will see simple configuration file for the screen. Here you can choose how many custom screens you want to have and also which one is displayed by default on the bootup. Please bear in mind that changing current screen on the device will override the file, so Gauge.S will always boot up to the screen you used last. Param object lets you choose what grid sizes you want to run. The options are from 1x1 grid up to 3x3 and any combination of them. Once you set it, you can set the names and which display mode should each parameter be. Note that both can be set in the device itself with methods as shown in level 1 configuration, and then it will override it. So make sure after setting up number of screens and the grid sizes, press save and restart the device. You can then modify it and reload the file. For further tweaking, please note that capitalization of parameter names matter when setting it up, so you can get names from config.json and Gauge.S wiki for predefined ones. Histogram object is XY plot of the device. Type specifies whether you like to see min, max and trade displayed values. But as before stated, this can be always set up in the device itself. Let's now head on to setting.json file. Here you can set up most of the options and behaviors of your device. You can change your connection credentials, and if you have good antenna and close by router, you can put your Wi-Fi SSID and password so it automatically connects to your home or garage network. Time-saving feature is that you can set up FTP server to automatically upload log files. You can use your home NAS system, for example, and log files will be automatically updated during bootup. Delete after upload will remove files after successful auto-upload to FTP. Force Wi-Fi will make your device always start with Wi-Fi connection. For your protection, it's advised to turn it off once installed in the car. You can always force Wi-Fi connection either from menu or holding button during boot screen. You can also set your time zone and GMT offset. Those are default to UK time zone. Config part lets you choose things like GPS support if module is inserted. Smaller values of max log speed in Hertz will make CSV logs files weight less at sacrifice of time resolution, but I found 15 is good middle ground for most cases. Autolock enabled will trigger specified in config.json parameters and conditions, for example wide open throttle lock when you put down your throttle. Lock from start will force device to lock every time it's plugged in. In general, it's not recommended and it's based to rely on autolock enabled logging. Beta versions is only for those who want to experimentally test new features. But reporting is important and those versions can be unstable and potentially lock your device. Also, do not worry if you ever make mistake while editing files. Built-in editor will tell you once there is any error, but beware as helpful comments will be classed as errors too. It's important to always remove comma on the last member of object or array. Can Sniffer is memory-intensive feature that lets you view and log all or selected frames once hooked up to ECU. It's mostly geared toward reverse engineering and writing your own definitions. And while we're at it, every parameter you can see on screen is either predefined in Gauge.S code or defined with config.json file. This is the main file that lets you configure everything to your liking. Occasionally you might want to update your config.json to either match your engine ECU, or you want to modify parameters to show them in freedom units instead of globally appreciated metric system. In 99% cases, provided definitions for a car should work. As you get your Gauge.S for E36, it has definitions for MS41.0, but if you have version from another market or you have swapped the engine, to properly display some parameters you might need to download right definitions from our GitHub. Then either copy-paste its contents into config.json found on the SD card, or remove the file completely and rename new file to config.json. You can do this of course by taking out SD card and connect it to your PC or Mac, or using Wi-Fi, whichever is easier for you. It's impossible for me to go through everything that you can do in Gauge.S, as because of using massive expressions and functions inside them, those parameters are Turing complete. Although I picked some examples that may show you possibilities on how to interact with the world outside. Let's start with basics. Header is the name of parameter. This is most important one as we can refer to it from other parameters with this name. If you want to change to, for example, translate it to another language, it's best to use alias as this would display your things on the screen properly but keep the logic between parameters intact. Unit is self-explanatory. You can use dec to set how many decimals will be used. Min and max are only for predefined graph ranges and they have no other uses. If not explicitly set, device will automatically determine min and max value for nice and easy rate of change visualization. Hidden flag is for hiding parameters we don't care displaying, and no log for skipping them on log files completely. Reset time will let you choose time for auto min and max resetting, while 0 it will only respond to manual reset from the device. Flash point: once parameter will be equal or higher, the screen will flash. This is usually used with conjunction with MPA threshold for shift lights. You can also set it up for many parameters, for example oil or coolant temperature to warn you when your car is too hot. Auto log point lets you trigger logging to SD card when parameter is above set value. Default CAN speed is 500. Each parameter requires CAN ID in either decimal or hexadecimal value, but note that later requires use of 0x inside quotation marks. With K-line parameters, you can query your issue with a certain command, and setting up force KWP at the top will let you choose this protocol instead of DS2. Address will send a message and wait for response. This response is then loaded into response array. Both K-line and CAN will require offset, length and conversion factors. For K-line, offset is the number in whole array response, and CAN bus is offset within a frame, so usually from 1st to 8th byte. Length is defaulted to 1 aka byte, but can be changed to 4 bytes long. Conversions can be handled twofold, simply and fastly with mul and add, which follows formula mul times x plus add, or you can use expressions and set more advanced nonlinear conversions. You can specify up to 3 different parameter names for each expression. You can skip x and will default to this parameter, but usually those are used in separate parameters to make some calculations. Here is example how fuel usage liters per hour is calculated from engine speed when fuel injection is in milliseconds. You can also use Boolean and bitwise logic in the expressions, making it really easy to integrate triggers like this one warning about not revving engine when it's cold. I think most interesting are functions. Those can make faster internal calculations or control device in various ways, like use PWM PID output, control brightness, or simply make button be controllable by external sources. Here is example of such usage of functions to control device buttons. First, we query 2 CAN bus parameters from E36 or E39 chassis type. First, one will tell us configuration of pressed buttons. Second one will get us a flag for cruise control activation. If cruise control isn't active, we check which button is pressed and act accordingly. First place in the function is 0. This one replicates on main button behavior. The next one is confirm select button, and the last two is right and left ones. As we do not care for either seeing or logging those parameters, we keep them completely hidden. Another example is using setBrightness function to get one of analog inputs and connecting it to one instrument cluster internal light bulbs with 6.6K resistor and capacitor. This way we can use internet voltage divider to bring voltage down to safe levels, and then use LUT table function that converts the values from the left X column to values to the right Y column and interpolates between them. So now when our lights are out, we assume it's day, so our screen is fully on, but when we turn on the lights, we can control and match the screen brightness to our backlight. There are many more functionalities hidden inside Gauge.S. I try to document them on wiki pages, but some of them are discovered by other users and shared on our Discord channel. And I recommend you to go there if you want to learn more. I will assume you have some Arduino or embedded development experience. If not, I would advise you to start with something easier and find tutorials that let you play with blinking LEDs and so on. ESP32 requires basic knowledge of FreeRTOS to be used correctly, and this is out of scope of this video. If there will be interest in this topic, I can create more tutorials in the future. I also created few libraries for those boards already, so you can start developing with ease now. First, get Visual Studio Code on your computer and install Platformio from the Extensions tab on the left. Then, once installed, head out to Platformio icon on the left and open Home. Go to Platforms, Embedded and search for Espressif32 and install it. Then follow the link in the description and head to update the repository on my GitHub. I created simple sketch with all pins defined for all PCB versions. Click green code button on the right and either download it as a zip, or if you can use Git, then I don't really have to tell you what to do. Unpack in an easy to reach place and open in VS Code. Open platformio.ini and set PCB there that is right for your board. If you use version 5.0 or newer, you also need to set different board configuration. Then go to main Gauge.S repository and make sure to download latest firmware as a backup. Put it on the SD card so you can always go back to original after playing with the board. This is how to set up the board. Lay it down as I did and connect to at least 5V supply. I used some simple pair of 18650 batteries. They can power the device for over 20 hours. Take your SD card and connect it to your PC, then drop previously downloaded firmware on it, rename to update.bin. You can also use SD browser. Just go to gauge.local on your browser and select the file. It will be automatically renamed to update.bin, then just press upload. SD card is now ready. Don't put it in just yet, we'll now flash the device. I use this simple FTDI programmer, but it's important to remember to remove or bend out VCC, so voltage, pin out. Connect it to PC and pick appropriate COM port in Visual Studio Code at the bottom of the screen. Connect it like this. To orientate it well, ground pin of the programmer is on the top. Make sure all pins are well connected. Then take something to tie together two pins at the top. You need to use your second hand to press and hold buttons while doing that. Then lift reset button with both buttons still pressing. Make sure two pins are still connected. If this is successful, you can now progress to programming the device. Press upload and monitor and wait for flashing to complete. Once it is completed, press reset and observe serial monitor. Without SD card attached, it should throw warning. Put your SD card in and you should see information about firmware being uploaded. If successful, the device will reboot and you are good to use Gauge.S exactly as you did before. Here is close-up of two pins and the whole PCB, where in the bottom right corner you can see version of PCB. In this case it's version 4.3. Moving forward from version 5.0 of PCB, it doesn't require such juggling and you can just use USB to both power the device and upload your code. You also do not need to press any buttons as programming is handled through your USB connector. I advise you to keep this code as a basis of your development. You can always have easy way to go back or upload your own code to the board with your own binaries. Of course, the most advanced part of Gauge.S is its built-in game, Snake. Now with more fruits and 2 lives, so you can really go wild with your high scores. I hope you enjoyed the video and thanks for staying with me and my products. This year we'll bring more add-ons and gadgets to Gauge.S ecosystem, like 8-channel exhaust gas temperature sensors of a CAN bus, button boards and analog input boards. So as always, stay tuned!